Welcome back, my friends. Today let's talk about both R and Python. Both are fantastic tools for data science and I appreciate them both. So in that sense of appreciation, let's talk about features that R has that I wish Python had and features about Python that I wish that R had. And I know you can do all of the things that I'm going to show you today in either language, and this is because both languages are really capable of doing data science stuff, but sometimes I feel like one language solves things nicer than the other, and in today's video I kind of want to show you these kind of situations just as a way to highlight things where one language could learn from the other. So with that said, let's dive in. The first thing that I want to highlight from the R language is the pipe. This is such an incredibly cool tool to chain together multiple operations without having to worry about intermediate results. Let me show you how that works by running a simple data analysis. In my R script, I can take, say, our favorite Parma penguins dataset that just contains a bunch of data on penguins. And then I can use the pipe to pass this dataset, this tibble or this data frame, whatever you want to call it, pass it to a function that can deal with such a thing. In this case, I pass it to the select function that can select a couple of columns for me. And once this operation is done, I have, well, the result of that, and I have only the few columns that I want to look at right now. And then without having to save the intermediate step here, I could chain this to the next function using the pipe operator once again to mutate this data set, which means to calculate new columns, where I say, okay, let's calculate a new column called ratio by dividing the bill length column by the bill depth column. And once I execute that, we see that, okay, there is a new column inside of my data set. And once I'm done with that, I can pass this along to the next function to summarize this data set and then calculate things like the mean ratio. And if I were to do that, I'd get one value, but I could also say that I want to do this for every species in my data set. And then I'd have the mean ratio for every penguin species inside of my Parma penguins data set. So that's really neat. I didn't have to save any intermediate variables. I could just chain together a couple of really fundamental steps in a data analysis. And this is a really nice feature that the pipe allows you to do. And of course, this isn't unique to R anymore. Inside of the Python world, there's the polars package that allows you to do very similar things. If we jump into a Python script, we could use polars to read a data set. We execute that, we see that we have the exact same data. We could then use the select method that is integrated into a polars data frame. This would look something like this. That way we'd have selected only the columns that we want. And then we could do a with columns method command to calculate a new column. There you go, there's another column. And then we could group this thing, which will return a group data frame. And then we can aggregate things to calculate the mean ratio just like we did before. So really this way of chaining things together also works within the Python world, but the nice thing about the R world is that this chaining together is so common and it works out of the box with R. For example, back in my R script, I could take a look at a vector of strings. And then with this pipe operator, you could take this vector, which you can think of as a list if you come from Python, and then pass this to the next function that does something with this. In this case, I want to use the str_trim function to get rid of additional white space in front and at the end of the text inside of my vector. And then I could replace all of the white spaces, well, not the white spaces, I want to get white spaces for the underscore characters that I have inside of my data set. So if I were to do that, I'd have replaced all of my underscores like I wanted to. And then I could also chain more steps into this because probably I don't really care about these two texts here. Maybe I want to calculate their text length, in this case 21 and 10, and then I could say this vector is nice, but please sort it for me. And then I could take this result, save it into a variable, and I wouldn't have to worry about any intermediate step. So nowadays, this kind of step-by-step procedure is really common in R. And I know if you come from the R world, you might complain that, hey, wait a second, these str functions, they come from an additional package called tidyverse, and this is technically not R out of the box. And you are actually quite right about this. So to please these kind of complaints, let me show you that this exact code could also be replaced with functions from base R. And if I were to just throw in this code, then you'd see that it works exactly the same. It just has a couple of other functions that don't have as nice an interface as these other newer functions. But in principle, this idea of chaining together things works really well, even if you stay within base R. In contrast, what you'd usually do in Python is to first save this as a list, and then you'd start with a list comprehension to iterate over this list, and then you'd chain together a couple of string methods. This works really nice in this specific example. But then if you want to do this sorting and counting characters kind of stuff, you'd have to wrap the length function around the trimmed text. And then if you want to sort this thing later on, then you'll have to wrap the sorted function around the list comprehension. So all of that, if you execute this, it of course works and gives you the results. But in my humble opinion, this is not as easy to read as this step-by-step approach. And also it is not as easy and nice to write, because I kind of have to switch between first chaining together things, then wrapping stuff into a list comprehension, and this doesn't flow as nicely as this pipe thing. To be fair though, I kind of try to be really balanced here, because I know there is a lot of fighting sometimes going on between Python and R, but to be fair here, you can do a similar chaining workflow inside of the Python world with polars as well. So if I were to throw in the corresponding polars code in here, you'd see that it kind of works the same. You start off by making the list into a series, and once you have that, you can chain together methods from these polar series, and once you do that, you can chain together things like we did previously. So technically this also works, but I feel like this isn't as common to find in the Python world as compared to this kind of workflow, probably because you don't want to import polars as a dependency just to, well, sort this kind of stuff and so on. Anyway, if you enjoyed this video, make sure to hit the like button to let both me and the YouTube algorithm know that you enjoy this kind of technical content. This really helps me a lot, so I appreciate that. Thank you for that. And now let's get back to the video. So that was the first thing that I see as R's strengths, and within these few examples, we have already touched on two other strengths I want to mention. The first one here I want to mention is lazy evaluation. If you take a look at the R code, you'll see that species and bill length and bill depth, these are all column names from our data set. So if we were to look into this, then we'd see that, okay, there are these columns of our data set. But if I were to simply execute this species command, if you want to think of it as a command, if I were to just call this, we'd get an object not found. Yet I was able to successfully use this exact thing within the select function. And the reason why this works inside of select and not outside of it is because R lazily evaluates things. If we just take a look at this thing here, R doesn't complain about species not being known at the time of the start of the calculation. But once this code starts to execute, we are within the scope of the select function, and the select function actually knows that species is a column name inside of that data set. So that's why in this scenario this kind of code works. And this is so baked into this tidyverse and the R language that it is really common to find this sort of lazy evaluation where you don't actually have to wrap names into quotation marks. Compare that with the equivalent polars code. There you see that all of the column names, they are wrapped into these quotation marks. If I were to take them out, then you can already see that there is an undefined name species, and if I try to execute this stuff, we already get warnings. This sort of thing isn't appreciated inside of the Python world of data science, so we have to escape these things using these quotation marks. The same thing applies for this calculation in the with columns. We can't just divide bill length by bill depth like we did inside of this code here, where once again we use lazy evaluation to just grab the correct thing at runtime. No, we have to say that, okay, this is a string and it corresponds to a column name that we also specify by this polars.column function. So this is a different way of writing things, and whenever I work with polars, again, I really like polars. You should also check out my polars guide if you haven't seen it. It's a great getting started guide. I kind of forgot to mention this. There should be a link popping up right about now. But back to this issue at hand here, we kind of always have to use these quotation marks here. So even though I like polars whenever I write it, I'm kind of annoyed that I have to wrap things into these extra quotation marks. Again, it's not too bad, but when I compare it to the easy to write workflow inside of the tidyverse, I always feel like, okay, this would be faster within this tidyverse thing. So that was the second thing I wanted to highlight as part of this example here. And the third thing that I want to highlight inside of the R language is the thing that everything is vectorized. What we've done here inside of our examples that are just working on vectors is to pass this whole vector to a function, whether that's a base R function or a tidyverse function. The idea is still that we stick a whole vector into a function, and this function automatically operates on every element of that vector. That's typically referred to as vectorized calculations, and in R this is used so much. And I really like this because it makes it really easy to just take my vector. If you're from the Python world, you can think of it as a list. Just take my list-like thing and throw it to a function, and then it is processed and every element is then updated according to what that function does. In contrast, in the Python world, you always end up with these kind of list comprehension, which are also nice, but honestly, in a lot of cases, I'd prefer vectorized calculations over this list comprehension thing. But then again, to once again be balanced, if we talk about comprehensions, dictionary comprehensions in Python are kind of more convenient than the equivalent inside of the R world. So if we were to take our text entries, we can do a comprehension using for as in text entries, and then we can do, say, okay, the first entry or the first character of my string, that's supposed to be the dictionary key, and it is supposed to map to the full text. Of course, that's not kind of a nice thing to do here, or like a sensical thing to do, but just to show you that this stuff works and it gives you a dictionary here. That's a kind of neat thing of doing stuff. That's where I appreciate Python more, because you can have inside of this dictionary arbitrary objects and you can name the keys quite quickly. In R, if you use list, where you can also stick in everything you want, you often end up naming these things in a separate calls. So the keys are not set at the exact same time that you fill the values. Alright, so these were the three things I wanted to highlight inside of the R world. Now let's talk about the Python data science world. And for that, let's start with an R example first. If you've seen my video on S7 classes, then you know that I'm a fan of them. They kind of allow you to bundle things together, which are a neat way to, well, bundle things together for functions later on. If you've seen my S7 video, then you already know this example. If not, feel free to watch this video later on, but don't worry, you can just still follow along quite well here. I will explain the necessary stuff, but S7 classes can do way more. Check them out after this video. For now, let's load the S7 package and then create a new patient class that is simply a list of a couple of properties like name, age, height, and for each of those properties we associate a data type. Age should be an integer, name should be a character thing, and so on. And then once we have such a class, we can, for example, define a function. Let's call it ATHLYTICZ, and this takes as an argument a patient, which will later on be a patient object, and then it simply prints some data as a fake analysis into the console. And here really all I'm doing is to access properties from my patient object using this @ sign. And in order to show you how this actually works, let me define a patient, which is just done via calling this patient class using the specific properties, and then you can call this ATHLYTICZ function on the patient we've just created. And if I were to execute this stuff here, we see that everything runs through, and inside of my console we see that my analysis was printed. Again, in this dummy example, we just print some random stats about this patient. So this is nice, but in the Python world you can do a little bit better. For example, if I were to try to change something inside of this ATHLYTICZ function, then you'd see that, okay, if I'm using this patient, then use the @ sign to access an attribute, we see that R cannot give me any hints. How should it? It doesn't know that this thing later on is a patient, so that's why it doesn't know that there is this property name. So that's kind of inconvenient. I always have to remember what options are available. Let's go into the Python world to compare. So inside of my Python script, I could do a similar thing like I've just done in R. I could load a package that allows me to use data classes. Then I could define such a patient data class using this add data class thing. I'll talk about that in a second. And then I can define an analyze patient function just like I did before. And then I can actually create a patient and then call this function I've just created on the patient I've just created. And then if I execute all of this, we see that the exact same thing works. So that step is exactly identical, works pretty much the same. But what is nice is that inside of Python, if I were to try to access the patient now, you can see here that in the Python word, you don't use the at, but the dot sign to access attributes. If I were to use a dot, then just like in R, out of the box, nothing really happens. There is no helpful pop-up window that allows me to pick the thing from the list of attributes. But watch what happens if I tell this function that, hey, this thing will later on be a patient. I can use these type annotations to specify what my inputs will be later on. And now if I try to access some properties using the dot, then we see here that I'm already being shown all of the things from my data class specification. And I could say access the age here. So that's really helpful and it's really neat. And it allows me to write functions more smoothly by just denoting that the input will be a patient, which is a collection of all the things I need for my analysis. And then inside of my function, I can just the argument name and then access stuff using the name. So this is one of the things where I like Python really a lot because it helps me as a developer by leaving notes for myself later on what I expect as inputs and outputs. And there's more to be said about type annotation here, but I just wanted to skim the surface. And this also brings me to my next highlight from the Python world, namely that the developer tooling is so powerful. We've just seen that my IDE allows me to access stuff due to the type annotation, and you can already see that this annotation that you can do is well integrated with the tools that we use for development. But there are also a lot of other things that help me as a developer when I'm writing Python code. For example, you can already see here that the code that I have here, it's underlined saying that rough tells me module level import not at the top of the file. Get hints to follow specific notations. So let's stick this over here. But before I paste this code, let's also note that this thing here now is underlined saying that within this file, the tools detect that this data class won't be available. But the moment I stick this into my file, then the underline here is gone and everything works. And I also don't get any hints that this import should probably be at the top of the file. So with these kind of additional things that I installed, so if you take a look at my extensions, you see that this rough format is there that helps me to follow these best practices of, for example, defining stuff at the top. But my point here is that there exist these tools and they are also well integrated. Rough also does different things for me. For example, if I were to use single quotes here instead of double quotes and I hit save, which automatically formats everything according to rough standards, then you see that, okay, this was made into double quotes now. And this sounds mundane, but it's a really neat feature because it allows for standardization, and I can't count how many times I've tried to look for a string inside of my R code using text search. So for example, doing Control F and then looking for, I don't know, underscore. Then I of course find this, but inside of the R world, I have no guarantee that I might not have written this thing with a single quote here, and then this text search won't find the stuff. That's kind of tedious, and these kind of tiny little things are an example of how the developer tooling really assists the developer inside of the Python world. Not saying that R doesn't have nice developer tools, it does, but sometimes I feel like that's one strength of the Python ecoverse where I get even more assistance from the tools that I have at my disposal. Finally, let's talk about the last highlight I want to focus on inside of the Python world, namely about this add data class thing. More importantly, about decorators in general, because this thing here is just a decorator decorating stuff. You see inside of the Python world, let me just scroll down to throw in another example. In the Python world, there are these things called decorators. Technically, they are just functions returning other functions. So if I just throw in this code here, ignore it for now if you don't understand what's going on. It's just a decorator that allows me to decorate a function. And what it can do is to take a simple function like we have stuff here that just divides numbers and modify its behavior. Let's just take this function here and divide 10 by 2. So if we were to just execute this stuff here, we see that the result is 5. Shocking, I know, but that's what we get. But what we get when we throw a 0 into the second argument is an error because we're then dividing by 0, which is obviously a serious no-no. But what we can do with the decorator, for example, like this, is to modify the behavior of our function, and the modification that this particular decorator is supposed to do is to return a default value when something goes wrong. So what I can do now is to use this add handle except and say that the default response when something goes wrong is supposed to be return 0. So what happens now is that if I re-execute this part to let my function know that it is decorated, now if I re-execute this stuff here, we see that there is a warning, but there's also the default value that we return here. I could also stick in a different thing like value. Then if I were to execute this, then we see that the function instead returns the string value. The nice thing here is that I can just take my existing function and throw a simple line on top of that, and then the behavior is modified automatically. And don't get me wrong, in the R world there are also nice ways to make functions handle exceptions well. For example, let's head back into our R script and then let's stick in a function that also divides numbers, and then we could do divide numbers and divide 10 by 2, and then we get 5 again. And the funny thing is that inside of the R world you could actually divide by 0 and you get infinity as a result. So to throw in something that causes an error, let me throw in a text of 0, and then you'd see here, okay, this doesn't work. So inside of the R word you can also make this safe. You could wrap this divide numbers function into the per package function called possibly, and in there you could define the otherwise value. In this case, let's just do 0 and save this as a save divide numbers function. And then if you execute only this part, you see that, okay, this is just a function and you can actually call it using this, and then you'd see that you get a 0 result back instead of an error because we have defined this as our default value here. We could also do default, and then we'd see that this is the thing we get back. So there are similar mechanisms inside of the R world to modify function behavior, but if I had 10 functions and I want to make them all safe, then I'd also have to wrap them into possibly a couple of times and duplicate stuff. And again, it works, it's nice. This possibly function is actually a really nice function. I talk about this in my data cleaning masterclass where I talk about functional programming because it is such a powerful technique and it allows you to do a whole lot of fancy stuff. I really do enjoy this stuff, but sometimes when I'm working with Python and I just throw a decorator on top of a function, I'm thinking, hey, this would be really cool to have inside of the R world as well. Right, everyone, we have now covered all of the things that I like about the R world and the Python world. Maybe not all of the things, but a whole bunch of things I like about them. Let me know in the comments if you enjoy these kind of technical videos about both R and Python. Also feel free to mention stuff I forgot. Of course, make sure to hit all of the button, like button, subscribe button, and so on. And now with all of that said, I say thank you for watching and I'll see you next time.